Chemistry. All right, guys, welcome back. This has been a hard unit so far because there's a lot of stuff to remember. We're doing reaction types and predicting products, okay? So far, what you've learned is you've learned about the reaction types. You've learned how to predict the products by identifying the type of reaction. Now you can predict the products, and you can actually write out these products using your bonding rule. So now we have a full-fledged equation here, but we're not quite done. Let me give you an example of an equation, and let's say I have H2SO4 plus, I don't know, NaOH, and it's going to give me, let's say I follow my rules. Okay, this is a double replacement reaction. I know the two back guys are going to switch. So I know that hydrogen is going to get the OH, right? So I'm going to end up with HOH plus sodium is going to get the sulfate, Na, and he was a 2, so he's going to give the 2 to him. They were all the rest 1s, so it's SO4 right there, okay? That's because I already know the oxidation numbers. Well, I undid the swap and drop. He was a 2, hydrogen's a 1. If I looked up sodium, he's a 1, hydroxide's a 1. So if I did swap and drops, all I did was switch the back guys. Hydrogen got the hydroxide, right? And sodium got the sulfate. Right here, I swapped and dropped. Now, we're not quite done here. We're not quite done. Now, this is a great job if you made it this far. You were able to see the reaction type, double replacement. We were able to predict the products. We're going to get water and sodium sulfate, and we were able to write out from bonding, swap and drops, and all that stuff, right? So we did it all. Now, we're almost done. Now we have the last part of our lesson, balancing equations. Now, the reason why we have to balance is because of this thing called the law of conservation of mass, okay? Now, whenever you hear that word law of conservation, the rule is always the same, whether it's mass, energy, whatever the law of conservation is, it means the same thing. It means we cannot create, we cannot destroy. All we're allowed to do is rearrange, right? So we can't create and we can't destroy. All we can do is rearrange. I don't know how to spell that. Rearrange. Okay? So everything I do has to follow this law of conservation of mass. This is a universal law, the law of the universe. The universe says I can't create anything. The universe says I can't destroy anything. The universe says all I'm allowed to do is rearrange. So let's look at my equation here. Does it follow this universal law? We're going to separate the reactants from the products, okay? Because the universe says everything I have on the reactant side, I have to have on the product side. I have to, because I can't create, I can't destroy. So these sides have to be equal when it comes to elements. So let's look at something here. I have 2 hydrogens. There's another one here. So a total, I have 3 hydrogens on this side, right? How many hydrogens do I have on this side? 1, 2. Oh no, it doesn't follow the law of conservation. Looks like I destroyed a hydrogen. So that means this equation's no good. I destroyed a hydrogen. Let's keep looking here. I have 1 sodium on this side. How many sodiums do you have on this side? 2. Oh no, I've created a sodium. So in this reaction, I've destroyed a hydrogen and I've created a sodium. I'm not allowed to do that. So how do I fix this? You fix it by balancing the equation, okay? How do you balance an equation? We're going to add front coefficient numbers to balance, okay? So first, let's talk some basic math here, okay? We're going to do some basic math before we work on this problem, okay? Let me give you a quick example here. Let's say I have Mg3PO4 2. Okay? So we're going to break some stuff down here. Remember in math, anything in parentheses, if there's a number outside, he multiplies everybody inside. Okay? This is basic math, right? So as of right now, we have actually, what this parentheses with the 2 out here tells me, we have 2 phosphoruses and 8 oxygens. Because if you see a parentheses with the number on the outside, it multiplies everybody on the inside. Okay? So that's the first big thing you got to understand. Anything in parentheses, if there's a number out there, it multiplies everybody in the parentheses. Does that include this guy? No, he's not in the parentheses. He only multiplies everybody in the parentheses. Okay? Now let's talk about front coefficient numbers, okay? Because this is the heart of balancing. Now, when you go to balance equations, you're only allowed to change the front coefficient number. You're never allowed to change anything in here. You can't. This is set because we've created this. This is the reactants. This is the products. We identified the reaction type. We swapped and dropped. We created the new compounds. This is right. When you see the formula is right. We just have to balance it to make it straight for the universe. So one side equals the other side. Okay? So now let's look. Let's say I put a front coefficient number of 2 right here. Now, this guy, this front coefficient number, he's called a coefficient, he is going to multiply everybody in the whole equation. Okay? He multiplies everybody in this entire equation. So now let's do some counting, okay? So we know right here, let's do that because we got to do this too, right? So we have 8 oxygens, right? This says we have 8 oxygens. So if there's 8 oxygens right here, because 2 times 4 is 8, what's 8 times 2? 16. So total we have 16 oxygens here, okay? Now, how many phosphoruses do you have? Well, we have 2 phosphoruses, right? And another 2 phosphoruses. So what's 2 times 2? So that means we have 4 phosphoruses. And finally, what's 2 times 3 here? Because we got 3 magnesiums. That means we have 6 magnesiums. So that's how you count when we're dealing with balancing and coefficients, right? There's 2 things you got to keep in mind. The coefficient multiplies everybody, and if you see a parentheses, that little number on the outside multiplies everybody inside the parentheses, okay? Later on, I'm going to teach you how to make this a lot easier, this polyatomics. So, before we start balancing, I'm going to give you my patented balancing rules, okay? Let's call these Mr. Lucier's patented balancing rules. If you follow my rules, guys, you will always be able to balance any equation anybody ever gives you. Okay? Rule number 1, we always balance from left to right. Okay? We don't want to be jumping around, starting someplace weird. You start from the left and work your way to the right. Okay? You start from the left and work your way to the right. Rule number 2, I call this the combustion rule. Combustion rule. If you're dealing with a combustion reaction, okay? If you're dealing with a combustion reaction, you're going to first balance the carbons, then the hydrogens, and you're going to save oxygen for last. Okay? Balance carbon first, hydrogen second, and oxygen, let's say, last. Good. Rule number 3, the polyatomic rule. This one is super important, and this one made balancing so much easier. In fact, if you can master the polyatomic rule, you could get into college and balance equations better than the people who are in college. because a lot of them don't know this rule, okay? The polyatomic rule is, if you see the same polyatomic on both sides, right? If you see the same polyatomic on both sides, I mean reactants, products here, you're going to keep the polyatomic together and you're going to balance it as if it's one element, okay? Keep the polyatomic together and balance it as if it is one element. This is a lifesaver. But the kicker is the same polyatomic has to be on both sides. It has to be on the reactant side and it has to be on the product side. Rule number 4, the final rule. This one also saves tons of time. I call this the hydroxide water rule, okay? This is the hydroxide water rule. Now the way this rule works is if you have hydroxide on one side and water on the other, side, right? It doesn't matter who is who. Hydroxide could be on the products, water could be on the reactants, or vice versa. As long as you have hydroxide on one side and water on the other, or water on one side and hydroxide on the other. If you have hydroxide and water and they're on opposite sides, here's the trick. You're going to take water right here and you're going to turn it into HOH and then follow the polyatomic rule. Remember, if you have the same polyatomic on both sides, you can keep it together. So you're going to balance hydrogen and you're going to balance the hydroxide separately, okay? This one is a lifesaver, guys. I can't tell you. Rule 3 and 4 are lifesavers. They save you so much time and effort, okay? The polyatomic rule, if you see the same polyatomic on both sides, balance it as if it's one element. Hydroxide water, if you see hydroxide on one side and water on the other, change water into HOH and then follow the polyatomic rule, okay? That's it. These are my patented rules to help you balance any chemical equation. So let's go back to our example here. Rule number 1, we're going to balance from left to right, okay? Rule number 2 is what? The combustion rule, but this isn't a combustion, so I ain't worried about it. Rule number 3, the polyatomic rule. We'll look at that. And then rule number 4, the water hydroxide rule, okay? So let's do the first one. We're going to balance from left to right, but I'm going to check and see if I can apply some rules here. Look, I have sulfate on this side, and I have sulfate on that side. So I'm going to treat sulfate as if it's one guy. I can keep it together. Now, you see the way I wrote water here? In my head, I already turn water into HOH, but normally on a piece of paper in a test, other teachers, they're going to write water as H2O, right? But look what I have here. I have hydroxide on one side and water on the other. So what I'm going to do is I'm going to take this water and turn it into HOH. I already do it automatically. So I follow the polyatomic rule now. I can now keep hydroxide as one compound, okay? So now that I've got my polyatomics all blocked up so I can see them, now it's time to balance, okay? So look, I'm going to start from left and work my way right. Remember, the arrow is your separation line for counting, okay? I got to make this side the same as that side. So let's do it real quick. I have 2 hydrogens. Look, I only have 1 hydrogen. Remember, we don't count that hydroxide. That's not a hydrogen, that's a hydroxide. So I have 2 and I have 1. Well, how do I turn this into 2? Well, I add a big old 2 coefficient. Now I have 2 hydrogens, 2 hydrogens. So we're good so far. Now we're going to do sulfate. Sulfate's next in line. I have 1 sulfate here, right? Don't say 4. That's not a 4. That's sulfate. I have 1 sulfate. How many sulfates do I have over here? I only have 1 sulfate. Remember, if you had more than 1 sulfate, you'd have something like this. SO4 parentheses with some number beside it, right? That means you have 2 sulfates. But do you see that here? So you only have 1 sulfate. So sulfate is good. It's nice and balanced. Next in line is sodium. I have 1 sodium. 2 2 sodiums. So I got to make this 2 sodiums. So how do I do that? You add a 2. Okay? Good so far? Okay. Now, 2 sodiums. Now I have, look, 2 hydroxides. Let's look right here. You already have 2 hydroxides. So if I'm looking now, it's balanced. Anywhere you did not put a number, you save this for last. You take care of the blanks for last. So I didn't put a number here, so he gets a 1. I didn't put a number here, so he gets a 1. So the coefficients for this equation is 1, 2, 2, 1. The coefficients for this balanced equation is 1, 2, 2, 1. Now my equation is happy. It's nice and balanced. What we have on the reactant side is equal to what we have on the product side, and the universe is happy. Okay? The universe is happy. So my rules work, guys. Now I'm going to add one more rule to this, okay? Because you might run into this. I call this the even-odd rule, okay? What happens is sometimes you're going to hit a situation and you have 2 sodiums on one side and 3 sodiums on the other. If you reach this type of predicament where you have an even number, 2 on one side or 3 on the other or whatever, what you're going to do is you're going to double the odd one and start completely over. You're going to double the odd number and start completely over as if you haven't done any balancing, okay? This one will help you a lot. So let me give you an example. Say I have Mg2 on one side and Mg3 on the other side, right? So I have Mg2 on one side and Mg3 on the other side. And I have to do coefficients. Here's my arrow, right? Well, the even odd rule say, okay, I got 2 on this side, 3 on this side. How am I going to make this? Because if I double you double the odd guy. How do I double it? You put a 2 coefficient there. Now how many magnesiums you have? You now have 6, right? You now have 6. By doubling the odd guy, right, in an even odd situation, and you start completely over, that'll make this an even so you can balance it, okay? By the way, how would I balance this? If I have 6 magnesiums here, what number do I have to put here to make it 6? 2 times what is 6? You put a 3. Now it's nice and balanced, okay? So guys, you might want to write these rules down when you start balancing because they will help you out. Here they go right here, my balancing rules. Use these rules and balancing will always be easy.